Hello, welcome back to BLENDERSUSHI LiveNoding. In this episode, we're gonna take a look at like a classic problem that we already done in the past, but I want to revisit it once again. It's a problem of if you have an object and you want to do like a slicing and procedurally. So I have this setup that's kind of doing it, and in this case, you might see that there's a cylinder and there's a bunch of monad nodes. And so what's going on here really? This is in the monad itself. Basically, I start with the cylinder, and then inside the monad, they're actually doing the same procedure, doing the same stuff. If I jump inside it, it's basically look at the cylinder and then look at the number of the integer seed here, but that's not so important. What I created here is like a single plane that's doing a cutting using the CSG boolean, and that's actually doing one job. It's basically generate a plane, randomize the rotations of the plane, randomize the position of the plane, and then cut the cylinder using the CSG booleans. That's exactly just one procedure. And if I go up, you can see that I'm using like the piggy-back kind of connection here, the same cut with different in different places, and then randomize it a few times. And I'm only doing like 4 cuts, and at the very end I'm actually removing the double, separating the loose part, so we end up with these pieces. So there are, like I said, there are multiple ways to do this. If you want to do it manually, you can definitely do that as well. But if you are doing it manually, for example, you start with just a simple cube, and then you create a plane perhaps, and perhaps you put it like that, and then you want to use like a solidify on the plane just to make some kind of thickness. And with that thickness, we can divide this cube by into two parts simply by using the boolean, and I believe it's probably intersects, actually more like difference. So you can see that's actually the cut that I did just now using Sverchok. This is if you want to do it manually. Of course, you can repeat the process, like if you duplicate this guy and make another, just randomly rotate the plane, and you want to make another cut, you go back to the original box, and then you add another boolean, and you want to do another difference, and using the second plane, and you get the second cut. I believe that's a clean cut there. And you do that repeatedly and over again. Perhaps you want to randomize it, you do it manually like this. So if I apply the boolean, we end up with this kind of objects, and then we can separate by loose part, so we have different pieces. So that's actually the process if you're doing it manually. You can of course do this using Python script, but I want to do it using nodes. So let's start. So we have nothing in the scene. I'm gonna save this. So this is like a Boolean combo monad. Let's try to make a single cut first. So we start with a box. Use a viewer draw. And we have our box there. We can resize it. Make it like 4. I think 4 is pretty good. And we know that we want to do a Boolean cut. So this is, we set it up everything first, and we're gonna do difference. So this is gonna be the original box object, and we just need to provide the plane to cut this object. So let's create a plane, and let's fill the plane object. Give it a different color. Okay, that's it. By default, the plane is being generated like that. We want to center it. The step is actually controlling the size of the plane. Let's make it 15, so it doesn't matter. And then we want to solidify this guy because we need some kind of thickness if you want to use a CSG boolean to end differences. Vertices and polygon with a bit of thickness, so it looks something like this. Now you can see there's a thickness. 0.1 is actually quite large, but that's okay. And after we use the solidify, we just simply plug that into this guy, and the final result is the box being cut like that. You can see there's a hole, like a cut there. For this thickness, we can actually make it smaller now. 0.02. Okay, that's better cut. It's like very thin slice. So that's the first step. First step, we're done. So that's the process. You can see this is the original objects, the box, and this is all the cutting process. And you can keep adding stuff here, but it's totally up to you. With the plane itself, with this guy, we know that we can rotate, we can scale, and we can reposition this guy simply by using matrix apply. Matrix apply. So this is one way we can kind of transform the plane from the original position. Now we just use matrix in. With matrix in, by default, the scale is actually probably 0, 0. Just in case, I'll plug in 1, 1, 1 to the scale, so we can actually scale the plane now. On top of that, we want control over the locations, so we can kind of move it slightly if you want, randomize it. And then the rotations, that's important, is the rotations. We can give a vector in and the angle. The rotation needs some kind of value. If you want to rotate it in Y, for example, 0, 1, 0. See, that's actually doing the cut. While we are rotating this guy, maybe I can turn into outline. Oh, actually, how to turn this into outline? It doesn't matter, just hide it. So it's doing the cut while we can rotate, and we can change this rotation, of course. For the rotation, really, for the rotation axis, I just use random vector and just use number of 1 and then put it there. Now we can randomize the seed, and we have different cut. In fact, the random vector can also be used for the locations. So that's a random cut right there. The angle can be a little bit higher. See, that's random cut. Okay, that's, I think, our function is kind of almost ready for the monads and the funky stuff. So you can see this is the original one, and this is the process. This is all the procedural process. The rotation, transformation, perhaps the scaling as well. Yeah, and we want to turn this into a monad. That's basically it. So this is the original object, this is the final one, and we want to select this middle part and turn this into a monad. I just use space and then type monad, create monad from selected nodes. So it's like it's gonna be grouped. So now we are inside the monad. Double check if we have everything correctly. So this is the output. Okay, CSG boolean output. What's the original? The original is this this box object. So that's okay, that's correct, and we just need to go up, and we can see our box. and our output. And the cool thing about this is we can replace the box with anything, maybe like sphere or maybe the monkey head, any kind of geometry you can pipe it in. And this is the monad, let's call it cutter. You can call it ninja, doesn't matter, samurai, cutter. But you can do this multiple times. But before we do that, we need to go back inside and then make sure that we also have another control. So we don't make the same slice all the time. We want to randomize it using the seed. So plug in the seed outside. Now we have control over the seed. See, as I am changing the seed number, the cut is being created differently. I can bake it just for a test, and then this is the bake version. This is a box with a single slice. I can separate it by a loose part. Now this guy's two objects. You can see this is the effects of Boolean. Sometimes it's doing this separation. In order to fix that, you probably want to use a remove double somewhere here. Remove doubles. So for every cut, it will try to merge the separated bits. So now let's go back, try again, randomize the seed and bake it, separate by loose part. Now let's check our result. See, clean cut, no other extra parts. There's another way to do this as well. If you use the bisect operations, bisect kind of, if you're doing a cut and then you use the bisect operations, it will get rid the other half and keeping this side. You can do that as well, but in this case I'm just using Boolean for simplicity. Okay, then we have a single cutting procedure here. The cool thing about Monad is that if you go Shift A and look under the group, you see a cutter. You can reuse that. This is the whole process now inside a group, and so you can pipe this guy in there and pipe this out and then randomize the seed, and you have another cut. Say there's another different cut, and it's actually quite clean as well. And you can do some kind of piggyback here. So you have two cut, select both of them and duplicate it and try do it again. So I don't know the limit of this actually. Maybe there's some kind of limit, but I don't know. I haven't found a limit yet, and I'm not sure if this will crash at some point, but it looks like it's pretty stable. Like I said, you can do the whole thing if you know Python and just use Blender BPY, Blender Python, and just for every Boolean cut, you set it up using script, and then how many cuts you want to specify, maybe 20 cuts. You can do that using Python, and that's actually probably the most ideal setup. But in this case, I'm showing it to you how we can do it using node space procedural setup, Sverchok add-on. So this is very powerful kind of method. Just make sure that the seed is different for each one of them, and it should be good. And the process might be a little bit slow after a while, but I don't know. It's definitely worth trying. See, now it's having difficulty. Maybe I hit a bad spot there. Did I save it? Yeah, provide it. Cool. Let's change this to 500. We could actually have a single number. I'll save it again. So you have, if you want to randomize every seed, you start with a maybe integer value, this guy, and for each one of them you can perhaps just multiply it. I'll just use addition and just add 20 to it. So this guy can go to that seed, and then the next one goes into the next seed, and so on and so on. So this is like the piggyback kind of method. It would be nice if we have some kind of a loop system in Sverchok, like that can do this kind of procedural cutting. So we kind of looping and then feedback the same objects as a result. So anyway, I just use 4 of them. Now, whenever we make changes for one seed, it will update accordingly. We can test it out. So the result is not always perfect, but this is a procedural. Sometimes you get kind of something that's like a process that's hard to calculate, and then it's kind of slow down. But anyway, you can make a bunch of different variations very easily. So we have already like 3 different results here, and we can separate by loose part, center, origin to geometry. And if you want, you can scale it, scale individual origin. There you go. You can make it, turn it into like a rigid body dynamic and just drop it, and it's become like some kind of like a rubble. But this is only for an object like this. I haven't tried with like more complex objects, but it's all, I think, Blender Boolean itself that's actually being used in Sverchok. This is CSG Boolean that's Blender provides. That's actually pretty fast and it's pretty stable and clean. No different from the Houdini one, I think. Yeah, so yeah, that's pretty much it. Actually, it's very basic concept. This problem we already saw it a few times in my live noding video, but this is, I think, kind of it's more elegant. Look at it. The nodes is like you might have seen this kind of piggybacking of nodes in a compositor or in the cycles material. It's a similar kind of ideas, and yeah, if you understand this, it's kind of it's a good concept to understand for you to try it yourself. So it's supposed to be like that. Okay, that's pretty much it for this live noding. Thanks again for tuning in. If you have any comments, feedback, suggestion, let me know in the comment section below. And I guess I'll see you in the next video. Thank you.